Hello everybody, myself Prasant Mukhopadhyay, faculty member Electrical Engineering Department, Greater Kolkata College of Engineering and Management. Uh, we have so far covered up to Unit 2, where we have discussed about the fundamentals of AC windings, air gap EMF distributions in concentrated in distributed winding. And in the second unit, or Unit 2, we have studied about the pulsating and rotating MMF. So, what is constant magnetic field for MMF? What is pulsating? How different pulsating MMFs are being added up, and how pulsating waves are created in winding, especially separated or especially placed at 90 degree apart. And also we have seen how three windings spaced 120 degree apart and supplied with balanced or uniform alternating current produced three pulsating MMFs, and when they are added up, the resultant MMF is rotating with a constant magnitude and with a synchronous speed in the air gap. And with this, prior knowledge, will start the Unit 3 with this will be on induction machines. Here in this unit, we'll study the construction types, that is what type of induction machines are there, induction motors, the squirrel cage and slip ring, their torque slip characteristics, starting and maximum torque, equivalent circuit, phasor diagram, losses and efficiency, effect of parameter variations on torque slip characteristics, variation of rotor and stator resistances, stator voltage and frequency, and therefore different methods of starting, braking and speed control of induction motors. And then when induction machine operated as a generator, that is generator operation, when it is self-excitation, WFET in induction machines. So these topics will be covered in this unit, that is in Unit 3 or Module 3. And the textbook mostly will follow. As I told you, I have given the name of the reference and textbooks, etc. So electrical machinery by P.S. Bhimra of Khanna Publishers, and electrical machines by Nagrat and Kothari by Tata Macro Hills, and of course electrical machinery by alternating current machines by MGC, and another one is the fundamentals of electrical AC machineries by Lansdorf. Other than that, we will follow Asfaq Hussain, electrical machines, and Mukherjee and Chakraborty, electrical machines. So these are the books, even Bandhavadhyay. So we'll follow in our this induction machines discussions. So let us start. We'll start with the construction of three-phase induction motor. You know, the three-phase induction motor is the most widely used electrical motors. Why I'm calling it is the most widely used induction electrical motor? Because almost 80% of the mechanical power used by industries is provided by this three-phase induction motors. Because it is simple, it is rugged or robust in construction, cost is very low, good operating characteristics, and the absence of commutator and good speed regulation it's a very say maintenance is almost nil. In a three-phase induction motor, the power transfer is transferred from stator to rotor through the winding, rotor winding from stator to rotor to the air gap by induction principle. So the induction motor is also called asynchronous motor because it runs at a speed other than the synchronous speeds. If it is it's the asynchronous motor particularly, not synchronous motor. Basically, its speed is below when it is run as a motor. Its speed will be below the synchronous speed, and if it is run as a generator, of course, its speed will be above the synchronous speed. So now. With this introductions, we'll talk about go to the construction of this three-phase induction motor. Now, like any other electrical motor, induction motor, a three-phase induction motor is constructed from two main parts, namely rotor and stator. As the name suggests, the stator is the stationary or static part of the motor, and because in stator the stator winding is placed in the stator of the induction motor, and three-phase supply is given to it to produce the rotating magnetic field, and which we have studied in our earlier module how rotating magnetic field is being created. And in the rotor, the rotor is the rotating part. Of course, the name suggests, since it is rotor names is coming from the rotating part of the induction motor, and it is connected. The rotor is connected to the mechanical load through the shaft. Okay. So the rotor of a three-phase induction motor again classified as squirrel cage rotor and slip ring rotor or wound rotor or phase wound rotor. Okay, so what we seen so far, we have seen that three-phase induction motor or induction machine have two main parts. Okay, one is stator, which is the stationary part, where the three-phase distributed winding is being placed among the stator slots of the stator core, and where three-phase balance supply is being provided to create a rotating magnetic field. Okay, and of constant magnitude, and of course of the synchronous speed, and this rotating magnetic field is being rotated through the air gap. And second part is the rotor, which is the rotating part, and it is to which the with the rotor through shaft the mechanical load is being coupled or connected. Again, the rotor further classified into two types: squirrel cage rotor, and another one is the slip ring rotor, which is also called a wound rotor or phase wound rotor. So depending upon the type of the construction of the rotor, this three-phase induction motor are classified as either squirrel cage induction motor or slip ring induction motor or wound induction motor or phase wound induction motor. Okay. So what I have seen. So we have seen that induction machines or induction motor has two main parts. One is stator, which is the stationary one, where the three-phase distributed winding is being placed and the three-phase balance supply is provided to create rotating magnetic field, which will this rotating magnetic field will rotate in synchronous speed through the air gap between stator and rotor. and the second part is the rotor, which is the rotating part of the induction motor, and it is with this rotor through shaft the mechanical load is being connected, or either by say different arrangement with the coupling or say belt pulley, whatever it is. Now this rotor again divided into two, whether squirrel cage rotor or slip ring rotor or wound rotor or phase wound rotor, and depending on this type of the rotor, depending on the type of this rotor, three-phase induction motor again classified as into main two section way, that is squirrel cage induction motor or slip ring induction motor or wound motor or phase wound induction motor. So now we'll talk about the construction part of the stator for both kind of say three-phase induction motor, whether it is a squirrel cage or wound rotor, whatever it is. So for this we are besides this other parts of three-phase induction motor shaft. I told you for transmitting the torque to the load, it is made up of steel, bearing for supporting the rotating shaft. And one of the problems with electrical motor is the production of heat during exertion. So to overcome this problem, we need a fan for cooling, which is connected in the rotor shaft. And for receiving external electrical connection, of course, the terminal box must be there. And there is a small distance between the rotor and a stator, which usually varies from say 0.4 millimeter to 4 millimeter, and this is known as the air gap. So if we quickly say go through the different parts, so what we have seen so far, so it has mainly main two parts are stator and rotor. And rotor are of course two types, squirrel cage rotor and wound rotor. And other than that, we have shaft for transmitting torque to the load, and it is made up of steel. Bearings for supporting the rotating shaft, and for during operation the heat is being generated for different reasons, and so dissipate this heat. A fan is being provided for the cooling purpose, and another is the terminal box or connection box through which where the stator terminal is being terminated and where the supply, external supply is being provided. And so stator and rotor will be placed in such a way there must be an uniform air gap between the stator and rotor. And this air gap, of course, will be of say 0.4 millimeter to 4 millimeter. And this air gap, so depending on the length of the air gaps, we'll see in our advanced classes that the overloading capacity, etc., depending on this air gap itself. So, that's actually the major parts of a three-phase induction motor. Okay, so then we'll come in details with of the different parts. We'll see how it look at how in what material these parts are being made of, and why, what is the reason behind the selections of this material, and etc. So the two major parts, stator and rotor, and then other essential parts like shaft, bearing, say fan for cooling purpose, external box, connection box, and of course maintaining. Now we'll discuss the stator of three-phase induction motor. The stator of the three-phase induction motor consists of three main parts. Actually, stator frame, stator core, and stator winding, which is used for producing the magnetic field, and that's why it is something called field winding. So, what are the main parts? Stator frame, stator core, and stator winding. So, one after another, we'll discuss. This is stator frame. This is a picture of the stator frame. So, stator frame is the outer part of three-phase induction motor. And what is its function? The main function is to support the stator core and the stator winding, and it acts as a covering, and it provides protection and mechanical strength to all the inner parts of the induction motor. And the frame is made up of either of die cast or fabricated steel, and the frame of three-phase induction motor should be strong and rigid, as the air gap length you see it is a 0.4 millimeter to 4 millimeter maximum of the three-phase induction motor, and so it is very small. So otherwise the rotor will not remain concentric with the stator, which will give rise to an unbalanced magnetic pull. And so that's all about the stator frame. Now come to stator core. So this is the stator frame, and this is stator core. So this is the stamping. The main function of the stator core is to carry the alternating flux. So in order to reduce eddy current loss, so this stator core are laminated. Okay, so these laminated types of structure are made up of stamping. So this is stamping, which is about 0.4 to 0.5 millimeter thick, and all the stampings are stamped together to form the stator core, and which is then housed in the stator frame. Okay, and the stamping is made up of silicon steel. Basically, it is used silicon steel to reduce hysteresis loss occurring in the motor. So stator core are made up of stamping, and it is laminated for eddy current loss, and core are made up of silicon steel to avoid or say reduce hysteresis loss in the motor. Now stator winding, which is also called the field winding, and it is provided on the slots of the periphery of the stator core, and it carries the three-phase windings, where the three-phase balanced AC supply is provided, and this three-phase edges of the windings are connected either in star or delta, depending upon which type of starting method we use. Mostly to start squirrel cage motor, start delta starter, and hence starter of the squirrel cage motor is delta connected to enable the use of start delta starter. So we start the slip ring three-phase induction motor by inserting resistance. So stator winding of the slip ring induction motor can be connected either in star or delta, and the winding wound on the stator of the three-phase induction motor is also called field winding, as I told you. And when this winding is excited by three-phase AC supply, it produces rotating magnetic field. So this is the figure of a stator winding. Okay. Now we'll talk about types of the three-phase induction motor, that is squirrel cage three-phase induction motor. And basically during our say first earlier, actually during these discussions of the three-phase induction motors, we have said now, depending on the type of the rotor, the motor is either squirrel cage or wound rotor. or slip ring rotor motor. The rotor of the squirrel cage induction motor is cylindrical and has its slots on its periphery, and slots are not made parallel to each other but a bit skewed because skewing prevents magnetic locking of stator and rotor teeth and makes the working of the motor more smooth and quieter. So we'll see later on so how the skewed stator help us to prevent magnetic locking of the stator and the rotor teeth. The squirrel cage rotor consists of aluminum or brass or copper bars. Uh, and these aluminum, brass or copper bars are called rotor conductors and are placed in the slots on the periphery of the rotor. And rotor conductors are permanently sorted by the copper or aluminum rings called end rings. And to provide mechanical strength, these rotor conductors are braced to the endings and hence form complete closed circuit resembling a cage, and hence the name squirrel cage, and hence the squirrel cage rotor winding is made symmetrical as endings permanently sort the bars. The rotor distance is quite small and it is not possible to add any external resistance as the bars get permanently sorted. And the absence of slip rings and brushes make the construction of the squirrel cage three-phase induction motor very simple and low cost, and hence widely used in three-phase induction motor. And these motors have advantage of adopting any number of fold pairs, and a diagram of squirrel cage induction motor having aluminum bars short circuit by aluminum end ring is shown here. So this is the squirrel cage rotor, and see short circuit. Okay. Now, what is the advantage? Advantage of this squirrel cage induction rotor is the construction. As I told you, it's very simple and low cost to target, and there is no brushes or slip rings, and these motors require less maintenance. Why it is applied? It is applied in a lathe, drilling machine, hand blower, printing machines, and many more. So list of application is not very limited. It's a very wide application area. Now we'll talk about slip ring or wound rotor motor, three-phase induction motor. Rotor is wound for the same number of poles as that of the stator, and has less number of slots and fewer turns per phase of a heavier conductor. Rotor also carries star or delta winding similar to that of the stator winding. Here it is shown. This is slip rings, this is the brush, and this is rotor windings. Okay. The rotor, of course, consists of number of slots, and rotor windings are placed inside these slots. Okay, and as the name suggests, slip ring induction motor consists of slip rings connected on the same shaft that of the rotor, and the three ends of the three-phase windings are permanently connected to these slip rings, and the external resistance can be easily connected through the brushes and slip rings, and hence used for speed controlling and improving the starting torque of a three-phase slip ring induction motor. And the brushes are used to carry current and to and from the rotor winding, and the brushes are further connected to the three-phase star connected resistance. Okay, and this is the shown electrical diagram of a three-phase. So this is your star connected rotor winding. This is rotor frame, and this is the slip ring, so the three phases are connected. Okay, and this is the external resistance, start factory rheostat. So it is. This is shaft. These are the brushes, and this is slip rings. So at starting, the resistance is connected to the rotor circuit and gradually cut out as the rotor picks up its speed. And when the motor is running, the slip rings are sorted by connecting a metal collar which connects all slip rings together, and the brushes are also removed. So this reduces the wear and tear of the brushes due to the presence of slip rings and brushes. The rotor construction becomes somewhat complicated, and therefore it is less used as compared to squirrel cage induction motor. And its advantage is it's having high starting torque and low starting current, and it has the possibility of adding additional resistance to control the speed. Um, and its applications, slip ring induction motors are used where high starting torque is required, like hoists, cranes, elevators, etc. Okay. And with this, we have found the difference of construction of squirrel cage and slip ring rotors, and say induction motor. Now, what is the difference between the slip ring and squirrel cage induction motor? See, slip ring induction motor construction is complicated due to the presence of slip ring and brushes, whereas squirrel cage induction motor construction is very simple. And for wound rotor or slip ring induction motor, rotor winding is similar to that of the stator winding, but in case of squirrel cage, the rotor consists of rotor bars, which are permanently sorted with the help of the end rings. Whereas in wound rotor, we can easily add rotor resistance by using slip rings and brushes, but there is no such provisions for rotor bars are permanently sorted in case of squirrel cage induction motor, and it is not possible to add external resistance. So, due to the presence of external resistance, high torque can be obtained for wound rotor or slip ring induction motor, but in case of squirrel cage induction motor, starting torque is low and cannot be improved. Whereas slip ring and brushes are present in case of slip ring induction motor, and slip ring and brushes are not present, as we have seen in their construction. And due to the presence of brushes, frequent maintenance or routine maintenance is very much required for wound rotor or slip ring induction motor. And squirrel cage maintenance is very less, almost maintenance free. Construction of wound rotor induction motor is complicated, again due to the presence of brushes and slip rings, and it makes the motor more costlier. And construction for squirrel cage induction motor is simple, robust, and cheap as compared to slip ring induction motor. Slip ring induction motor are rarely used. Only 10% industry uses slip ring induction motors. And whereas squirrel cage induction motor, due to simple construction and low cost, it is widely used. And wound rotor induction motor, rotor copper losses are high and efficiency is less. Whereas it is in case of squirrel cage, copper losses and is less and efficiency is high. Speed control by rotor resistance is possible for slip ring induction motor, but it is not possible of speed control by rotor resistance method. Is not possible because rotor resistance cannot be changed. Slip ring induction motor used where high starting torque is required. It is in hoist, cranes, elevators, etc. And squirrel cage induction motor is used in lathes, drilling machines, fan, blower, printing machine, etc. So that's all about the differences between these two motors, sleeping induction motor and sleeping induction motor. So with this, we will finish our